Hi students. Today I'd like to introduce you to the Crosby Machine Controller. The first thing you need to do to make it go is download some Arduino code using the Arduino IDE. The file you're going to be inserting is the Crosby Machine Controller V3. At the top of the code you'll see all the pinouts for how the connections are supposed to be made once you get back to Visual Basic. So, like any other Arduino program, go under Tools, select the COM port that the Arduino board is attached to, in this case COM4. Make sure you specify the board. I'm using an Atmega 2560. Compile the program and shoot it into the Arduino. Okay, that was successful, and I can close the Arduino environment, and I will open Visual Studio. Once you're in Visual Studio, open the Crosby Machine Controller V3. For this simple example, I'm just going to run it as is. So I'll press Start. There's the controller screen. You need to establish a USB connection between the Arduino and Visual Basic. You need to tell it what COM port the device is on. In this case it's COM4, and then hit Connect. In the Receive Data window you can see the conversation that's going on between the Arduino and VB. The way the controller works is Visual Basic is the master and the Arduino is the slave. So first Visual Basic tells the Arduino, send me a report containing the data with all the analog ports. Then it says, send me a report telling me the state of all the digital ports. Then VB says, set the digitals to a certain state using a formatted command. And lastly, it outputs a command to set a servo position and set the PWM variable voltage outputs. So let's see what that looks like. If I click D4 off, you can see it toggles and it says D4 on, and the little red LED in front of you comes on. I don't have 2 or 9 hooked up, but it works the same way. I have a servo, just a common model airplane servo attached to D6. You can see as I move the slider, the little pointer moves back and forth. So that's 0 degrees of deflection, and I can move it all the way over to 180 degrees. On D3, I have a pulse width modulation output. So you can see the little white LED is going bright and dim. The analog input values right now are junk. I don't have anything connected to it, so they're just picking up whatever stray charge is available to hit the pins. It could be noise from 60 Hertz AC, something like that. But as soon as you hook those up to an actual device, they read properly. And the last one is digital inputs. I have this yellow wire connected to 5 volts. You'll notice that those are also subject to stray charges. D13 says high. Well, it's not connected to anything. So it really doesn't know what state it's in. It's reading just whatever stray charge is available. But if I put 5 volts on D11, you'll see now it goes high. These should all be on pull-up resistors, and you'll learn about those in class. If I take the 5 volts away from D11, well, it still says high. until that charge bleeds off. And now it finally says low. If you have a pull-up resistor, that does not occur. It's instantaneous. So you always have to have a pathway to bleed off charge from a microprocessor. This should get you going, and we will have a better discussion of how this thing works later in class. Thanks.